Hi everyone. Today we will see longest common subsequence problem. First we will see what is a LCS problem. Here there are two strings, string 1 and string 2. We are finding the common sequence, largest common sequence between two strings. It is a classical problem. That problem can be solved using dynamic approach. Problem. There are two strings. The objective is to find the longest common subsequence that appears in both sequences in the given string by maintaining the relative order of characters, but that can be in need not be in continuous order, that can be taken by deleting some characters. A subsequence is a string that is a new string generated from the original string, including characters from the given string, and some characters can be deleted without changing the relative order of the remaining characters. For example, BCD is a subsequence of ABECFD. Here we have the given string is ABECFD. Sequence of characters are given. So we are taking substring BCD. Here AEF characters are deleted, and the order of the characters in the subsequence is in the same order in the given string. B after B, C after C, D. For example, CB is not a subsequence because CB is not in the same order in the given string. So this is the problem for finding largest common subsequence of two strings. And example, string 1 and string 2. So the largest common subsequence is BCAB. Here, some characters between two characters can be deleted, but the order of characters should not be changed in the subsequence. Here, there can be n number of common sequence between two strings. The problem is to find the largest common subsequence. That is, maximum number of characters in the substring is largest common subsequence. The first one is length 4. The second one, BDAB. And BCAB. There are two common subsequences. So there is a chance to have more than one answer, longest common subsequence. The problem is X and Y be two sequences and M and B the length of sequence respectively. To find the length of longest subsequence that is common to both sequences. Here subsequence is a sequence derived from two sequences that elements are common to two sequence by maintaining the same order of characters by deleting some characters from the given string. And what are constraints in LCS, largest common subsequence problem? The characters in the LCS need not be in continuous as in the given string. There can be multiple LCS for the same strings. So the some characters can be removed to find the subsequence, but the order should not be changed. Order of characters appear in the given string should not be changed. This example, BD, AB and BC, AB. There are two common subsequence of two strings. And how we can solve the problem? The problem can be solved using dynamic approach. Dynamic approach is a method of solving problems. Um, Here it used two concepts, that is optimal substructure and overlapping subproblems. What is optimal substructure? The problem is divided into n number of subproblems. The subproblems are solved if the subproblem appears more than once in the solution space. That result of one problem can be used instead of executing the same subproblem again and again. We can reuse the result of subproblem. The subproblem results are stored in a table that can be reused to find the result for the complete problem. Here in this scenario, we have the solution for subsequence. AB, what's the length, what's the BC. Then using AB, ABC can be calculated. If ABC is appears more than once in a solution space, that result can be reused instead of repeating the same execution. So finding this subsequence suboptimal structure, and that can be used to find the optimal solution to the whole problem. And second one is overlapping subproblems. That LCS used the concept of memorization in dynamic programming. The recursive formulation in LC helps in solving dynamic programming, while subproblems are solved and the solutions are reused to build up the final solution efficiently. Here the solutions can be reused. For example, take the problem L of S1, S2. So by removing this right part of S1, we can have the left solution and see the two circles, AEB, AB, ZE. The two subproblems occur in the solution space. Instead of executing the subproblem again and again, the problem can be solved and the results can be reused for finding the solution to the whole problem. And solving HCS using dynamic approach. Here 2D table or matrix is used to store the length of largest common subsequence at each and every steps. This table is filled from top to bottom fashion, but the result are derived using dynamic approach from bottom to top fashion. Here there are two constraints to find the LCS of two strings using dynamic approach. First, we are having two strings. For example, taking A and B. A and B are two strings. I and J are the index used to take character from the string A and B. I is index for string A, J is index for string B. If two characters are equal, then add one with diagonal element to the current position, one to the left diagonal element. And if two characters are not equal, find the maximum of previous row value and previous column value. That is, these two constraints are used to fill up the tables. If we are taking we are forming the table, m cross n table, all zeroth rows and zeroth columns are inserted to zero value. That is used for deriving value to the next one. So we are finding a of I and b of j value. That is LCS of I comma j. That is based on characters compared between two strings. If two strings are equal, add one to the left diagonal element. That is the current value. If two strings are not equal, take the maximum of previous column and previous row value. And steps. Initially, assign LCS of I comma j. So array name is matrix or two-dimensional table. Array name is LCS. I comma j represents the row value and j represents the column value of the second string. There are two rules to fill the table. Initially, zeroth row and zeroth column are filled with zeros. And apply the rule. The first rule is if two strings uh, the current characters are equal, LCS of I comma j is equal to 1 plus LCS of I minus 1 comma j minus 1. If S1 of I not equal to S2 of j, then find the maximum of previous row and previous column value. And how to find the length of largest common sequence. Fill up the table from top to right. The bottom right, that is L of m comma n. The last value in the matrix is the length of largest common subsequence. And how to derive a largest sequence. How to find the largest sequence. It's a bottom-up approach. From the last one, how we are getting that value, which method, there are two rules. Which rule gives the value and from where we are deriving the value. That arrow will be added from bottom L of mn place to the top 0, 0. M of n to 0, 0. Now, in this path, take only diagonal arrow. Diagonal arrow, when we are getting diagonal arrow, if two strings are two characters in the strings are equal. We are putting the diagonal arrow. That strings are added from right to left because we are deriving answer from bottom to the top. So add from right to left. Then find the value that is a common subsequence. So the output is length of largest common subsequence and the common subsequence between two strings. So the value in L is LCS of m comma n is length of largest common subsequence, and the string is derived from bottom to down approach. And we will see an example, string A and B. Now string A, there are 8 characters in string A. Here index starts from 1. So that is for easy implementation. You can start from 0 also, then you can change the logic. In this example, I am taking the index from 1 to 8. And string B, there are 6 characters. So the index is 1 to 6. Now I am constructing LCS table. That is LCS two-dimensional table. Here in the row wise, I am taking the string B. The column I am taking string A. So there are 6 characters, 6 rows in 2D matrix and 8 columns. That is a number of characters in string A is 8. So 8 columns in um, LCS two-dimensional matrix. Now 0th row and 0th column is added. That values are initialized with 0. That is used to derive the value from A of 1 comma 1. All the results are stored in a table. Here that current value is used to derive value to the next rows. So that is called dynamic approach. That is suboptimal solutions. Yeah, some subproblem solution is used to derive the solution to the whole problem. That is, and also overlapping subproblems. The results are reused. When we implement the LCS, we can reuse the solution of subproblems. That eliminates the re-execution of subproblems. It saves time. Then now we will see how to derive this table. So initially 0th row and 0th column assigned with zeros. Then how to find A of 1, 1. So take the first value LCS of I comma j. That is, if two strings are A and A is equal. Now add diagonal. Diagonal is 1. Uh, Diagonal is that is 0. 0 is added with 1. Thus we are getting 1. Next, A comma B. Strings are different. In that case, take the previous column and previous row value. That is 1 comma 0. Take the maximum. That is 1 is maximum. So like that, the tables are filled from left to right and top to bottom. That is row by row. In each row, column by column, the values are filled up by applying rule 1 and rule 2. Now the length of largest common subsequence is the value at the last place, that is LCS of 5 comma 8, that is m comma n, that is the 5. This length is 5. Now we have to derive the string subsequence, the largest common subsequence from this table. Now, how to find it? So, bottom to down, bottom to top, traversal from, that is bottom to top approach by dynamic programming. Here, take 5. So, how we are getting 5? Strings are different. So, we're taking maximum. So, 5 derived from this previous column 5 value is a horizontal arrow. And see here from next 5. How we are deriving 5? By adding 1 to the diagonal 4. That is a red arrow. By adding, why? Because the two strings are equal. How we are deriving 5? Take the row and column A and A. Two characters are equal. In that case, we are adding 1 with 4. So we are getting 5 derived from 4. So this is a diagonal arrow. Again, 4. 4 is derived. Here E and F strings are different. So we are taking the maximum of previous column and previous row. Maximum of 4 and 3 is 4. Now it's a horizontal arrow. No need to take again 4. 4 derived from two string characters E and E. Again it's a diagonal. So diagonal arrow. So take the string from the diagonal arrow. Here diagonal 4, a comma a5, again 4, that is e comma e, again 3, d comma d. So fill the strings from right to left. See here a, first one, then e, fill from right to left. Then because the bottom of approach, again 3 corresponding to character D, add D after E. Again, because we are getting two strings are equal, B and B. So add B. Again, diagonal value, 1, A and A. So it's equals. Now, take the string that is A, B, D, E, A. Is the largest common subsequence that is derived using dynamic approach from bottom to top fashion. So only take the element, take the character which gives diagonal, which goes diagonal. Now we will see the algorithm how to create, how to generate LCS of two given strings. Now create a table A of m plus 1, x of n plus 1 that store the length of LCS. So we are creating two-dimensional matrix. That is dimension is m into n, or we are taking with 0 m plus 1 or n plus 1. Initially assign 0th row and 0th column with 0 value. LCS I comma 0. This is 0th column is assigned to 0 and the 0th row is assigned to 0. That is the use of for loops. Again, how to fill the tables using recurrence relations. Take if x of I minus 1 equal to y of I minus 1, then if two strings are equal from the string 1 and string 2, add 1 to the diagonal value. So ij is current value. How to get the previous column j minus 1, previous row I minus 1. So add 1 to the previous row column value. Else, if two strings are not equal, take maximum of previous column and previous row. That is I comma j is derived from I minus 1 j and j comma I minus 1, whichever is the maximum that is taken as LCS value. Like that, we have to fill all the cells in the matrix LCS. Now, after this, all values are filled. Now, LCS m comma n is ready for finding the value. Now, the value found at the location, that is at bottom right, LCS of m comma n, this is the length of largest common subsequence. Return the matrix, then how to print the string. So we are, so bottom up approach, we are deriving from bottom to right, from right to left. The strings are filled with the characters from right to left. So for generate one character, I add at the front to generate the subsequence. So this is a code for generating strings. So we are starting from right. So if x of I minus 1 equal to y of j minus 1. So the diagonal value derived only by if the two characters in the strings are equal. That is, if x of I minus 1 equal to y of j minus 1, then add that value to the LCS string. Again, decrement the value. If we are getting, if two characters are not equal, we are taking only maximum. That case, we no need to add the character in the subsequent string. So this is the final code for printing the string in a reverse direction. So backtracking concepts, then program, how we can implement largest common subsequence algorithm in C language. Now, include the header files. Now we are taking two characters. That is we are taking as a character array. It's a character array. It's a string. Character star x, character star y. M is size of the first string x. Y is the size of second string y. Now we are assigning the array L of m plus 1, n plus 1. Here we are starting with 0. You can start with 1 or any concepts. So build L of m plus 1 and n plus 1 in bottom of fashion. So we are taking two loops, I0, J0. This is for comparison. If R equal to 0 and J is equal to 0, L of I comma J equal to 0. That is 0th row and 0th column is filled with zeros. Next, if x of I minus 1 equal to y of j minus 1. If two strings are equal, add 1 to the diagonal. That is, diagonal is L of I minus 1, j minus 1 plus 1. Else, if two strings are unequal, find the maximum of L of I minus 1 comma j and L of I comma j minus 1. That is the previous row and previous column value. assigned to L of I comma j. So this code returned the 2D table, that is L of m comma n. The value at L of m comma n is the length of largest common subsequence, and this is the code to bring the characters and how to build LCS string. After finding the table, then how to build the strings. So from bottom to down. So now take two index I equal to 0 and j is equal to 0. If we are getting one diagonal value if two characters in these two strings are equal, that is x of I minus 1 equal to y of I minus 1, we are taking the index. That character is taken, that is added in the from the right to left. So the finally LCS returns the largest common subsequence. So this is the main code. We are declaring two strings x and y. We are getting input from the users. We are finding the length of x and y. This is assigned to length m and n. Now the function is called LCS of x comma y m comma n. That function returns the value. That value is printed x, y, m, n, return 0. Now this is sample input and output. And what are the applications of LCS? This is mainly for character manipulation, string manipulations. When we compress the files or comparing the versions of documents, we can LCS is applied and bioinformatics. So there are sequence of DNA, protein sequence in DNA. For finding the DNA sequence or comparison, LCS can be used in bioinformatics field, and it is used for text processing and data differencing. For character processing, LCS can be used. The solution to the LCS problem is commonly solved using dynamic approach to efficiently compute the length of LCS problem. And when we come to the time complexity and space complexity, we are having mn dimensions of 2D table or matrix. The table size is m into n. M and n represents the length of string 1 and string 2. Here the time complexity is depends on the matrix size m into n. So the time complexity is order of m comma n. And the space complexity, how much space it occupies. That is the minimum of m comma n. That is the memory space occupied by the algorithm to produce the result. Thank you.